Hello, today we are going to factor trinomials when a is not equal to 1 and also using patterns. So before we begin, let's just remind ourselves of the general form of a quadratic. So we have ax squared plus bx plus c. A is always the number that is the coefficient in front of the x squared term. B is the coefficient in front of x, the x term, and c is the constant. If your equation has an equal sign, you always want to make sure that it is equal to 0 before you begin. These are the steps that we are going to use when we are factoring trinomials when a is not equal to 1. Go ahead and write down these steps. You will need to pause the video to write down these steps, and then we will apply them when we do an example. In our first example, we have 2y squared minus 9y plus 4. So, first we need to identify if we have a greatest common factor that can be factored out. In this case, there is no greatest common factor. So, we can proceed with step 2, which will be to multiply our a term and our c term. When we multiply a times c, we are looking for, or we are trying to identify, the factors of a times c, which is 8. So, let's list all of our factors of 2 times 4, which is 8. We have positive 1 and positive 8, negative 1 and negative 8, positive 2 and positive 4, and negative 2 and negative 4. In our next step, we're going to identify our b term, which is negative 9, and we're going to look for which two factors add to equal our b term, which is negative 9. So we're going to add these factors on the left and see what we get for on the right. 1 plus 8 is positive 9. Negative 1 plus negative 8 is negative 9. 2 plus 4 is 6. And negative 2 plus negative 4 is negative 6. So it looks like we have a winner in negative 1 and negative 8. Negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 equals negative 9. Now we're going to rewrite our trinomial with 4 terms. Our first term is going to be the same as the original, 2y squared. Our second term is what we get from splitting up negative 9 into our two factors that we found on the list over here. So we have minus 1y that came from this list and minus 8y that also came from this list. Our last term is going to be the same as our original trinomial, plus 4. Now that we have a polynomial with 4 terms, we can use factoring by grouping. So we'll group our first 2 terms and our last 2 terms. We need to look for what we can take out or factor out of our first binomial. In this first binomial, we can factor out a positive y. When we divide each of these terms by y, we are left with 2y minus 1. In my second binomial, I want to factor out a negative 4. I want to bring that negative out front so that when I divide, I am left with positive 2y minus 1. Now our two factors, 2y minus 1, match, so those can be factored out front, 2y minus 1, times the remaining factor, which will be y minus 4. This is now completely factored. Let's try one more example. First of all, we need to identify if we have a GCF. In this case, we do not have a GCF, so we just proceed as normal. Our first step is to multiply a times c. Let's list our factors of a times c, which is negative 6. We have 1 and negative 6, negative 1 and 6, 2 and negative 3, and negative 2 and 3. When we identify our b term, we're looking for the two factors that add to equal negative 5. When we add our list of factors on the left, our winning set of factors are 1 and 6. Negative 6, I'm sorry. So now we're going to rewrite this trinomial with 4 terms. The first term stays the same. The second term gets split up into our two factors, plus 1a minus 6a. And our last term stays the same as the original. Now that we have a polynomial with 4 terms, we can factor by grouping. Out of my first binomial, I can take out an a. I'm left with 2a plus 1. In my second binomial, I want to take out a negative 3, so then I'm left with, again, 2a plus 1. Now that these two factors are the same, we can factor them out, so we'll have 2a plus 1 times our remaining factor, which is a minus 3. Next, we're going to factor using some patterns. Go ahead and pause the video and write down all of these general formulas for factoring using patterns. Our first pattern we're going to investigate is the difference of two squares. In this first example, we have x squared minus 9. We need to identify what a and b are so that we can plug them into this general formula here. But what we're given is we're given a binomial where the first term is squared and the second term is squared. So we'll need to square root both of those terms in order to get a and b. Our first term, a squared, is x squared in our problem. So when we square root those, a is going to be equal to x. Our second term, b squared, is equal to 9. When we square root both of those, b is equal to 3. So in our general formula, whenever there is an a, we'll plug in x, and whenever there is a b, we'll plug in 3. For our first factor, we have a minus b. So our a term is x, our b term is 3, so we're left with x minus 3. Our second term is a plus b. Our a term is x, our b term is 3, so we have x plus 3. So this completely factored is the product of x minus 3 and x plus 3. Remember that you could always distribute to check your answer. Let's try one more. If we factor out our GCF of 2x, we're left with x squared minus 4. In this case, our a term will be x and our b term will be 2. So when we factor our difference of two squares, we'll be left with 2x times the quantity of x minus 2 times the quantity of x plus 2. Notice that the GCF just stays out front for your final factored solution. Finally, last one actually, we have x squared plus 16. Since this is a positive sign in the middle, meaning that those are being added, this is not a difference. This, therefore, cannot be factored and will be called not factorable. Let's try an example using the difference of two cubes. Our first problem, x cubed minus 8, we need to figure out what a and b are going to be so that we can plug them into this formula. Right now, both terms are being cubed, just like we have here. So we are going to need to do the cubed root in order to identify what just a and b are. Starting out, we have a cubed is x cubed. If we cubed root both sides, our a term is going to be x. Our b cubed term is 8. We can cube root both sides, so our b term is 2. The cubed root of 8 is 2. Now, in our general formula, wherever there is an a, we'll plug in x, and wherever there is a b, we will plug in 2. So our general formula, we have a minus b times the quantity of a squared plus ab plus b squared. Make sure you pay close attention to which signs you're putting in between all of these terms. So a minus b will be x minus 2 times the quantity of our a term squared, which will be x squared, plus our a and b terms multiplied together, plus our b term squared. We can simplify this a little bit to have x squared plus 2x plus 4. Here's one more example. I'm going to just show the answer to this one, so you should try this one on your own. Pause the video, try this one on your own, and then unpause the video to check your answer in your work. It's important to notice that once you get to the completely factored out form in the general formula, that this term here, this last term, can actually not be factored any further. So when you get to that step, your problem is complete. You are completely factored from here. Make sure you write down any questions you have about that second example if you have them, and we will go over them tomorrow. Our last example is using the sum of two cubes formula. In this last example, we have 8a cubed plus 27. Both parts of this binomial right here are being cubed. 8a cubed is being cubed, and 27 is also a cube. So in order to identify a and b, we'll need to cube root both of these terms. A cubed is 8a cubed, and b cubed is 27. When we cube root both of these terms, a is going to be 2a, and b will be 3. So wherever we have an a, we'll substitute 2a, and wherever we have a b, we will substitute 3. Our general formula is a plus b times the quantity of a squared minus ab plus b squared. Notice that our signage has changed a little bit from the difference of two cubes problem. So now let's plug in and substitute our letters a and b. A is 2a, so we'll plug in 2a, plus b is 3, plug in 3. A squared will be 2a, the whole quantity of 2a squared, minus a times b multiplied together, plus our b term squared. So when we simplify this a little bit, we have 2a plus 3. Remember that when you square something like this, you need to square both parts. So 2 squared is 4, and a squared is a squared. So we have 4a squared minus 6a plus 9. This is completely factored. Make sure you write down all of the questions that you thought in your head as you were working through these problems. We'll go over any questions you have and practice these a little bit more tomorrow. Have a great day.